Hello everyone, this is Team Bhiksha's batches and our project aims at generating memes using deep learning approaches. Here's the agenda for today's presentation. First we'll go through the introduction, then we'll describe the task, then go through the different approaches that we took, and finally show the results and talk about our conclusion. First, talking about what this project is all about. Recently, meme has become a new informal language for expression and communication. In this project, we are looking at different approaches to generate original and humorous memes in the style commonly found on the internet. Our work is based on the paper Dank Learning. Why this task is important? It's because we wanted to use both computer vision and NLP approaches for our project. We also want to see if neural networks can imitate humorous nuances while creating languages. On successful implementation, our work can be integrated in different social networking media to provide users functionality to automatically create memes on the images and then share it with their connections. For this project, we re-implemented the model described by the paper Dank Learning. The initial implementation was done in TensorFlow framework, but we tried to use it from scratch using PyTorch. We custom scraped 2,700 popular meme templates and created a dataset with 400,000 captions, and then experimented with different approaches to solve this problem. Here is the table that shows how our dataset looks like. The first column shows the image template. The second shows the description about the image. And the third column are the different memes that are associated with this image.
Okay, so in the baseline model, first the template image is embedded into lower dimensional space using the InceptionNet model. Then the template image description is embedded using average glove word embeddings. These two embeddings are then concatenated and fed through a fully connected feed-forward neural net. And then we use that output as the initial embedding for the meme caption generator, which is an LSTM.
We tried swapping different parts of the baseline architecture with other things to see what performance changes it brings. For example, instead of using Inception for the feature extractor, we tried using ResNet. Instead of using glove embeddings, we tried to use Word2Vec. And instead of using LSTM in a decoder, we tried using GRUs. And during inference, we tried both greedy search and beam search.
So we got pretty interesting results from our experiments. So as you can see below, these are completely new memes that were generated from our model. These texts were not included in our training data set right now. So the interesting thing that we found from our experiments was that the baseline model actually did the best with validation metric of 735, followed by our model with GRU, which had a validation metric of 1700. Then when we switched up the Word2Vec from GloveMid, it did a little worse, and ResNet did the worst for us. Okay, so this was a pretty interesting project, and we did end up learning a lot. In conclusion, our experimentation resulted in generation of some decent memes, and some of the results were pretty unexpected. We'll write more about that in our report. And one thing that we still haven't completely looked at is how attention-based models can be utilized to improve our current results. And we want further experiments to figure out how we can even improve and include the humorous nuances in the training memes to improve our results even better. So we are hoping in the future to use GAN-type models for the same. Yep. Thank you. These are the things. Thank you.
Thank you.